Welcome back to Dave Does Math from Home. This is part 2 of our video on cross products, section 13.4. I think I said all of the theoretical and meta cross product information that I needed to say in the first video. This video is just going to be some more examples. So if you think you have the idea down and solid, great. Skip this video, go do some homework. If you want to see more examples of me calculating cross products, that's all you're going to get in this video. So I'm just going to make up some more cross products. Like, let's do U is 3, 4, 5. And let's do V as negative 2, 1, and 1. And last time we did U cross V. This time, let's do V cross U. It's a little bit weird that multiplication isn't commutative in this sense, but it's also a little bit weird that there's two completely different multiplications, so I feel like this is the less weird thing that you'll experience today, so don't worry about that. We set this up as a 3 by 3 matrix, I, J, and K across the top. V is going to be my second row, because V comes first in this, so negative 2, 1, 1. U is going to be my third row, 3, 4, 5. If you get the order of these things wrong, you will have all of the correct numbers, but they will all have the incorrect sign. So everything that should be negative will be positive, and everything that should be positive will be negative. So that's what the order does. And then with this, we're going to we're going to do the determinant. These lines here mean the determinant. It looks like an absolute value. It's conceptually not completely separate from an absolute value, but it's called a determinant. And we do this by expanding across this row. So we're going to have an I times this cross thing, 1 times 5 minus 1 times 4. We're going to have a negative j times these guys, negative 2 times 5 minus 1 times 3. And we're going to have a positive k times these guys, negative 2 times 4 minus 1 times 3. So lots of arithmetic going on, lots of like trying to keep things straight. But once you have all this written down and you know where all the numbers should be and how they go here, it is just arithmetic and it falls out pretty nicely. 5 minus 4 is 1. Negative 10 minus 3 is negative 13, but it's negative j, so this will be plus 13j. And this is negative 8 minus 6 should be negative 14k. Let's check. I'm going to call this C for cross product, and I'm going to find the dot product of C and U. That should be 3 plus 52 minus something went wrong. Huh. 14 times 5 is 90. That's not 0. Oh, this shouldn't be a 14. I thought that was a 6. That was foolish. 8. This should be an 11. Which is 55. There we go. Ah, we got there. It's a good thing I have you to watch me to keep me honest, or I would just be making mistakes constantly. This is in fact 0. C times V is 1 times negative 2 is negative 2 plus 13 minus 11 equals 0. Perfect. So, it's a tiny bit embarrassing to have made an arithmetic mistake on my own video, but I think that I'm more proud of using this check to find the error and fixing it than I am embarrassed that it happened in the first place. So this is still, I think, a great example. We're leaving it in the video. I'm not going to edit this out or try to re-record this. This is good. I'll call this a success. Let's do one more and then call it a day on cross products. Oh, no, this is still part 2. Let's do 2 new vectors. Let's say I want to find 3, 1, 0, and on this one I want 2, 2, 2. We're going to add one extra little layer of difficulty to this. Instead of just wanting the cross product this time, what I want right now is the area of the parallelogram formed by these two vectors. So we're going to get the cross product, and then we're going to find its magnitude. So if you're finding the magnitude of something, it doesn't matter which direction it's pointing. It could be going this way, it could be going down. The positives and negatives are all going to get squared, so the magnitude doesn't actually matter for this. So for this kind of question only, the area of the parallelogram question only, it doesn't matter which one you do first. So I'm just going to do U cross V by creating this 3 by 3 matrix, I, J, K, 3, 1, 0, 2, 2, 2, which is I times 1 times 2 minus 0 times 2 minus J times 3 times 2 minus 0 times 2, so 3 goes 2, plus K times 3 times 2 minus 1 times 2. I realize that using all 2's across the bottom does not illustrate where these numbers are coming from very well, but just remember that for the I piece, you cover up the row and column for I, and you look at those two products. For the J piece, you cover up the row and column for J, and you look at those two products. And for the K piece, you're looking at those two products. So we can just do some arithmetic to figure out what this is. This looks like it'll be 2I minus 6J. 6 minus 2 is 4 plus 4K. So presumably this is the cross product. After my recent performance, I kind of don't trust myself, so I'm going to check this answer. Make sure that it's actually good. C times U is 6 minus 6 plus 0. That checks out. C times V is 4 minus 12 plus 8. That also checks out. So I'm now extremely convinced that this is the correct cross product of these two vectors. And now I need to find the magnitude of C. Area of the parallelogram is the magnitude of C, which is the square root of 4 plus 36 plus 16, which is square root of 56. I can probably take a 4 out of that. That's 4 times 19, so this will be 2 root 19. Beautiful. That's square root of 19 is a little more than 4, so this is 8.5. The parallelogram formed by these two vectors has an area of approximately 8.5 square units. I'm sure that's useful somewhere for something, but I don't know where or for what. Bye.